Hello, my name is WAIKINS. I'm a professional network trainer. I'm also a certified CCIE network expert with more than 25 years of working experience in IT industry. Today, we talk about the new CCNP Enterprise exam. The CCNP exam is the most widely recognized and respected certifications for networking in IT industry. The new CCNP exam this year has been changed by adding a new type of performance-based lab exam item. It is different from the previous exams with only dumb Q&A. It is very difficult for the students to pass this new CCNP exam. I'm going to demonstrate the solutions of one real lab exam item in the advanced routing of new CCNP exam. Let's take a look at the screenshot on the right-hand side. The diagram and information of this screenshot are collected recently from the real CCNP exam this year. This is the details of the original requirements from the exam. You can take a look first. Try to understand it by yourself if you can figure out the solutions. I have summarized it into simple points for easy understanding. There are two parts of this lab exam item. We work on part 1 first. The requirement is SW2 is only allowed to telnet from ISP routers loopback 0 using AAA services. What does it mean? Let's check on the diagram here. We have a loopback attached to ISP. This is loopback 0. We only allow this loopback 0 from the ISP telnet into this SW2 telnet OK. For all other telnet connections are not permitted. The telnet function is straightforward. Let's take a look at the configuration here. We can add the telnet related commands under the line VTY terminal. We can specify the telnet protocol first and add the authentication with a name. Refer to AAA services and followed by a local command. Further, refer to username and password. The second part is apply filtering with a name. Refer to this ISP access list. Only allowed loopback 0 to telnet into this SW2. Let's make a summary. We specify the telnet protocol, add the authentication with a name, refer to AAA services, and followed by a local command. Further, refer to username and password, and then apply filtering with a name ISP, refer to this ISP access list. Only allow loopback 0 to telnet into this SW2. This is all the commands we need for this telnet function of solution A. Apart from solution A, there is another solution B that can also do the same function for this telnet. First, we apply the filtering under the interface, and then refer to this ISP access list. Only allow loopback 0 to telnet, and deny all other telnet connections. Solution B is easier, but it is configured without AAA services. Obviously, A should be the most possible solution for this lab exam item. Now, let's do the test and verification in the router. We have already preloaded most of the commands into the devices. First of all, we need to know the IP address of SW2. We copy this IP address and put it in the east router. We need to ping it first in order to make sure it is reachable, and then we can do the telnet now. It fails. Yes, this is what we expected because we do not allow other devices telnet into this SW2. Then we can try the ISP router now. We have to ping it first and then do the telnet. It also fails. Why? Because we only allow loopback 0 from ISP to telnet into this SW2. Then we need to do something more. Let's check this command if there is any option we can use. For example, this source interface. We can specify the loopback 0. It seems good now. Very good. We can now successfully telnet into SW2 from loopback 0 of ISP by this command. Everything seems good. Now we have completed this portion. Let's move on to part 2. This is the details of requirements here. I have summarized it into simple points. Let's check the requirement A first. The east router needs to avoid spooning attacks. The solution is use this feature, uRPF, to fulfill the requirements. What is uRPF? This is what we call unicast reverse path forwarding. This is a security feature that prevents spooning attacks. This is the details of the theory. Instead of only reading the theory, let's explain it by a diagram. For example, we have a router here called R1. We need this router to access the destination network 2.2.2.2. In order to make it reachable, a static route has to be configured for this routing. This is the command of the static route. The static route uses this interface and point to the next hop, further access the destination network. After applying this static route, a route entry is generated in the routing table. This is the sole IP route, the route entry with this information, interface, destination, and next hop. Suppose there is a hacker or attacker trying to create a fake network with the same IP address. Like this, we have a hacker here. Create a network 2.2.2.2, trying to connect this network to R1. For this network topology, it will cause security breach if there is no additional feature applied on it, because it normally cares about the destination IP address. Then R1 will forward the traffic through this wrong path to the fake network. This is not good. To avoid this kind of spooning attacks, we can apply a uRPF security feature. Then it will check the routing table and make sure it will follow the route entry for forwarding the traffic through this confirmed interface. to the real correct network. The packet on the unconfirmed interface here will be discarded and dropped. Then this can fix the spooning issue. The configuration is so simple by just adding one command on both interfaces. This is the command we need. We can apply this command to our lab exam item. This is the interface we need to apply the command on it. It should be working now after applying the commands. Next step, let's check the requirement B. The yeast router is not able to ping loopback 16 of ISP. We need to fix this issue. With a limitation, it is not allowed to advertise loopback 16 into OSPF, and we cannot use the static route too. Let's check it by step-by-step analysis. First of all, in order to make the yeast router able to ping loopback 16 of ISP, under normal operation, we need to generate a loopback 16 route showing up in the routing table of yeast router. Let's explain it by the diagram for more details. We have a loopback attached to ISP. This is loopback 16. We need the yeast router to ping to this destination subnet loopback 16. However, it fails. We need to do something to fix this issue. There is a routing table in the yeast router. Suppose we should have route entry like this. If we can see the route entry of this destination network, then we can ping from the yeast router to this loopback 16. There are several methods that can achieve this goal. First, advertise loopback 16 into OSPF in the ISP router. Just type the command network like this. Second, apply a redistribute connector command to advertise loopback 16 into OSPF in the ISP router. Third, we can create a static route in the yeast router pointing to this loopback 16. All these three methods can generate a loopback 16 route like this in the routing table so that we can ping it from the yeast router. However, based on the requirements, all these three methods are not allowed to perform the task. Then, what else can we do? The solution is by simply adding one default route command under OSPF in ISP. This is the only command we need for this default route under OSPF. Let's explain it by showing the commands in the router. Our goal is to ping from the yeast router to this loopback 16. So first of all, we need to check the routing table of yeast router. Can you see any route entry for loopback 16? Not yet, right? Okay, we can try to input the level command in the ISP router. Then we can check the routing table again in the yeast router. Can you see that? There is a new route entry here. This is for the loopback 16. It seems good, right? Let's try to ping it. Yes, we can ping it successfully. However, we do not allow to use level command to advertise loopback 16. Then we have to remove it now. Okay, we check the routing table again. Make sure we cannot, we cannot see the route entry again now. What can we do? No problem. We already have the solution. We can just input the default route command in the ISP router like this. Okay, we check the routing table of each router again. Can you see that? There is a new route entry here. This is a route entry generated by the command we did in the ISP router. This is the command we just inputted. It generates a default route entry in the east router. We have the routing now, so we can ping it. Let's do it now. Yes, we can ping it successfully. Apart from the routing, we also need to add the security feature command. Then we can do it now. We have to check the interface first to see which interface we need to input the commands on it. Now we can input the security features command here. If we forget the command, we can use the question mark to give us some hints. It is easy, right? Let's do another interface here. We have to check the configuration again to make sure it is done. Yes, we can see it. Again, we can try to ping it again. Oh, it fails now. Why? Because the basic command of this security feature only apply for the normal routing. However, we are using default route. So we need to do something more. Then we need to check the command again. To see if there is any route, option we can use. Can we see that? There is an option here, allow default. The explanation tells us that allow default route to match when checking source address. This is what we need. We can add it now. Let's do it. We can do the same for another interface. Okay, check the configuration again to make sure it is done. Yes, it is done. Then we need to ping it again to make sure we can fix this issue. Okay. Yes, we can ping it successfully, finally. Okay, let's check the configuration again. Okay, and the ISP router, and also the SW2. And ping it again, make sure it is working now. Yes, very good. Everything seems good, right? Good. The final configuration fulfills all the requirements. Then we have completed this lab exam item finally. Let's summarize the commands that students need to input it in the exam for this lab item. First, we need to specify all the telnet related commands under line VTY terminal. Second, we need to specify all AAA services related commands. then we need to add the default wow command under OSPF. Finally, we need to add the security features command here. Different commands are required to apply on different devices. For example, SW2, ISP, is router. Remember to pay attention to this point. This is all we need for the configurations. Let's make a conclusion here. For this new lab exam item of CCNP exam this year, it is not difficult to configure and remember the commands. However, it is very difficult for students to handle the lab exam items by their own ability. You can try to study the lab exam item for the first time. Before anyone teaches you, you may not understand what is going on and what they are talking about. The most difficult points are, first, it is hard to understand the questions and requirements and what topic and skills they are talking about. Second, it is difficult to figure out the solutions. Even for an ordinary level trainer, not all of them are able to handle it. Don't worry, I am WAIKINS, the professional expert of level training, who can figure out the solutions for you and help you to pass the exam easily and quickly. We make the difficult and complicated theory and skills into simple idea for you to learn it. You can easily locate our website by typing www.waikins.com like this, or by searching the keyword WAIKINS in Google. You can find all the details of our networking course on our website. Feel free to contact us for any inquiries. Finally, just join us, learn the level skills, and save your time to pass the exam in one take. We make the learning fun and interesting. You will enjoy your studying if you join our course. Hope you enjoyed this lesson. Thank you for watching this video. See you next time. Bye-bye.